Before we get started with our notes on heat transfer, I wanted to take a second to actually show you how to cut out the foldable. Now, it's very important that as you're cutting, you only cut on the solid black lines. Okay, that's going to be important for a little bit later whenever you are actually putting these notes into your notebook. Now, unlike our other foldables, we're actually going to fold this one in a little bit different way. We're going to fold on the dotted lines away from this side that says heat transfer. So the easiest way to do that is to actually flip your square upside down and fold until you can just barely see the dotted line underneath of the word. And you're going to do that all 4 times. And make sure that you take the time to do it carefully, because if you do it sloppily, the edges won't fit together. And so each time I am just folding up until I can see the dotted line. And whenever you get done, you're going to have something that looks kind of like an envelope that you can open up. Go ahead and turn your foldable so that conduction is at the top. Conduction is when heat is transferred between materials that are touching, so things that are in direct contact. For example, whenever you slide down a hot slide in the middle of the summertime, your legs hurt, because the heat is transferred from the slide to your legs from the process of conduction. Take just a moment to pause and write this information down on your foldable. Convection. Convection is when heat is transferred by the movement of currents in a fluid. Remember, fluids are gases or liquids. So good examples of convection are whenever you have boiling water, the water that is heated in a pot on the stove. As it heats, it rises, and then as it rises, it cools back down and then sinks to the bottom of the pot. The same process occurs whenever you're heating your house. You might have noticed if you have a basement, the basement is always going to be a little bit cooler than the upstairs. That is because warm fluids are going to rise and cool fluids are going to sink. Take just a second to pause and write down this information. The final method of heat transfer is by radiation. Radiation is when heat is transferred through space, so no direct contact. The biggest and best example of radiation is when heat is transferred to us from the sun. Whenever you go outside, you can feel the heat from the sun, but you're not touching it. It's also not blowing at you through the wind. Another good example of heat from radiation is if you go camping or if you go out in your yard and you have a bonfire and you want to make s'mores. You don't have to touch the fire before it's hot. You can stand a few feet away and still feel its warmth. That's radiation. Go ahead and pause so you can write down these notes. The last thing we're going to talk about is convection currents. Heat from the core, the very inside of the earth, causes convection currents in the mantle. Remember, warm fluids, warm things are going to rise and cool things are going to sink. Go ahead and pause while you write down these in your notes. Now, before we actually glue these into our notebooks, you should have something that looks like this. And the top flaps are empty. Before you glue these down, go ahead and draw a good example in the top part of your notes. And whenever you have that finished, go ahead and put glue on this side that says heat transfer and glue it down into your notes so that conduction is at the top. Now, some people have asked me, can more than one type of heat transfer be going on at the same time? Well, let's go to the kitchen to find out. Helping me in the kitchen today, I've got Jada the science lab and Cleo the chemistry cat. All three types of energy transfer can occur at once. It's all just a matter of perspective. For example, don't try this at home without adult supervision. Okay, I've got a boiling pot of water here on my stove. Because my pot is in direct contact with my stove, that is being heated through the process of conduction. The heat then travels from the pot to my liquid, and it heats the liquid, and as the liquid is heated, it becomes less dense, it rises to the top, it gets further away from the heat source, and then it cools back down, and then it creates a circular pattern that continues. Those are called convection currents. You can see here, get just a little bit closer, you can see here I've got some quinoa in there, and they are moving in that circular pattern. The second example of convection, you can see the steam rising off of the top of my pot. Okay, because convection deals with fluids, and fluids are not only liquids, they're also gases. Steam is also an example of convection. Alright, that's why you really got to be careful whenever you're cooking, because you can get burned from the steam. It is still transferring that heat. Okay, the final example, I'm just going to move my pot here. Now, if I held my hand, and I'm not going to do it really close, if I held my hand like here, I can feel the heat rising off of my stove top. Okay, because I am not touching it, and because it's not being blown up to my hand by wind or gas, that is an example of radiation.